Suppose we are creating a pull request for NetEx, and that's for the AUX64 BL808 RISC-V single board computer. We are adding the GPL driver and the LED driver. These are the files that we wish to upstream to NetEx. We have the BL808 GPL driver here, and we have the AUX64 LED driver here. Now, these files were created with a very old version of NetEx, and NetEx changes every day. So before we upstream these files, we need to copy them to the latest version of NetEx. Here is my repository for NetEx, and here is my repository for NetEx apps. Let us refresh them to the newest version. To do that, click Sync Fork and Update Branch. We do the same thing for NetEx apps. Sync Fork, Update Branch. Okay, so now NetEx apps is the latest version. NetEx is also the latest version. Next, we create a new branch for our changes. I usually name my branches with a name and a number. So this is for GPL. So I have GPL2 already. I'll just create a new branch called GPL3. Okay, so this is from master. So from master, we create a new branch called GPL3 for NetEx and NetEx apps. My naming convention, I always use the name followed by number, GPL3, GPL4, GPL5, so we can track the generations of pull requests. If we ever need to squash any of the changes before upstreaming to NetEx, we can still go back and trace what happened in an earlier branch. And the rule is that we always test the same branch for NetEx kernel and NetEx apps. There won't be a mismatch between the kernel and the apps. We have created a GPIO3 branch of our NetEx kernel and a GPIO3 branch for our NetEx apps. Let us check them out from the repositories. We copy the URL. We create a new folder, GPL3, and we check out the files. Now, this is coming from a branch, so we change this to branch, and we will call it NetEx. We do the same for NetEx apps. That's the GPL3 branch. Okay, same thing, git clone, followed by URL. We are checking out the GPL3 branch, and we will call it apps. We have apps and NetEx folders. We're going to make some fixes to them, so let's go into VS Code. We have opened the GPL3 folder in VS Code. Next thing that we do is that we copy the modified files. Remember the files that we saw earlier on here? We have a script that will allow us to copy this easily. The script is located at gist.github.com/ lup yuan. That's Lupyuen. We head over here, paste it. There is a script called copy PR files. Okay, scroll down, and we have this script here. This just explains how we got these files by running this command line here. And we have this script that will copy the files from one repository to another. Let's just copy it over and paste it into VS Code here. We are going to copy the files from GPL2 to GPL3. So remember that GPL2 is our source folder. We will copy out the URL, copy link address, and check out the files for GPL2. We create a new folder for GPL2. Okay, let's just remove it. Do it again. And we check out the files from GPL2. Change the tree to branch, and WIP nutex, we will call it nutex. Now we're checking out the GPL2 branch containing our files that we want to merge, but it's from a very old version of nutex. In a while, we will run this script. This will copy the files from one branch, the GPL2 branch, to our new branch, the GPL3 branch. We copy and paste everything into the command line. Yep, the files are copied. Let's take a look. We check the changes. Yep, it seems that all the files here are copied. Once we are done, we commit the files. Normally, I would say copy from GPL2 to GPL3. So I know where the files came from. Commit and push. This goes to GPL3 branch. If we refresh this, yep, so we see the commits. The files have been copied from GPL2 to GPL3. Okay. Now we are ready to draft the pull request. To do that, let's create a GPL3 pull request. We click on pull request and new pull request. Okay, this step here, be very careful. We are not creating a pull request for the upstream nutex repository yet. We are going into our own repository because we want to create a private pull request for our own review. Remember that master is now synchronized to the latest version, right? So we are trying to merge the change files from GPIO3 to master. So again, this is our own private repository for our own private review. For internal self-review, we're not ready for the whole world. This is for our own use. Go ahead and create the pull request. Right. Okay, so let's just give it a name. This is for RISC-V/64 and GPL driver and LED driver. We're going to talk about these three sections, but let's go ahead and create the draft pull request. Okay, so select draft pull request, right? Because we are not ready to merge it yet. We're going to review this. Now we head over and check the files that were changed, right? So we see what's the effect of this. Okay, that looks normal. Yeah. We see the files that we change. Git ignore probably shouldn't be changed. This will ignore later, right? And these are the files that will be merged in. Okay, this is a bit odd. We shouldn't be doing a linker script, and we shouldn't be doing this either. So this will be excluded later. So when we create a draft pull request, you can see all the files that will eventually go into mainline LaTeX. We can see which files that we should omit. So now that we have the draft pull request, we can do our build and test. So we need to make sure that these files are okay. What we do is that you head it back up to the GPL3 folder. Normally, to do a build and test, we go into the LaTeX folder. We do a tools/configure. This is for Org64 NSH, and we will do a make like this. Then once you're finished making it, we can run this on Org64 emulator. And we test the Rust Blinky application to make sure that it works. If we have an actual LED, we should test it on a real Org64 board. Right. So once everything is tested okay, we can head back to our pull request and fill in all the details. Here is our pull request. Let's head back up here. Conversation. Now, let's talk about these things. Summary, impact, testing. For summary, we will put normally 3 things. What, why, and whence. Let me explain. What? We explain this pull request. What is it for? This pull request will add a GPL driver and LED driver to the Org64 RISC-V SBC. Why are we doing this pull request? Well, that's because we wish to use the GPL driver and LED driver for a Rust Blinky application for the Google Summer of Code. Whence? Where did this code come from? Right? Did we create it from scratch, or did we copy it from somewhere? In this case, our GPL driver comes from BL602 GPL driver. We copied the code from LaTeX to LaTeX, but from BL602 to BL808. If we are copying code from GPL, yeah, let's be very careful about that. This is about the provenance of the code. We have an article that explains the pull request in more detail. Just head over to login.github.io. That's LUPYUEN/articles/PR. If you open this article, you'll see a lot more details about how we create a pull request. Okay. The impact section. Over here, we talk about impact on Org64. With this pull request, Org64 will be able to use GPL pins and will be able to blink the LED. Impact on existing code. This code is new. It affects only Org64, so therefore there is no impact on existing code. Right. Testing part gets a bit complicated. We need to do 2 types of testing. We need to copy and paste the expected test log. So remember earlier on we said that we will build and we will test and we will run this on Org64 emulator or a real Org64 board. Well, we will copy and paste the entire log and paste it here. So this is the expected test case. How it is expected to work, what is supposed to show when we run this on a real board. Now, something else is also very important is regression testing. We need to put in the regression test log. How can we be sure that the things that we're doing here will not affect the old code? So we need to figure out, is our code going to affect RISC-V platforms or ARM platforms? And we can do the regression testing on QEMU emulator. QEMU for RISC-V or QEMU for ARM. Now, then there are various flavors of LaTeX for QEMU, 32-bit or 64-bit. Sometimes you need to test both versions, 32-bit and 64-bit QEMU. Also, NUTEX has got two flavors, NUTEX flat mode and NUTEX kernel mode. So sometimes you need to do regression testing for flat mode and kernel mode. We end up with a whole bunch of test logs here. It could be QMEU, RISC-V, 32-bit, flat mode, QMEU, RISC-V, 64-bit, kernel mode, and so on and so on. Right? So why are these logs useful? Well, in case of problems, we can go back to this pull request and compare the logs and see what has changed. Right? So this is a very good way to troubleshoot problems in future. So we're doing a huge favor for people, for NUTEX developers on the future. Sometimes I also do a video demo because a video demo, like a link to YouTube, is good to capture the actual runtime performance. We know how exactly this thing runs, how fast it runs, or how slow it runs. In case later on we get complaints about the slow code, we have the YouTube video with the timings inside to compare. So take your time to fill in these things, and we'll do an internal review, the text here, as well as the files here. When we are finally ready, we will create a new pull request. We'll come back here again. We will say new pull request. But instead of creating in our own repository, we will do it upstream. We will do NUTEX master. This means that we are ready to go public with our pull request. And remember that we do it from same branch, GPL03. Okay, yeah, so I won't do this right now because we're not going public. So let me just close this. Let's talk about breaking into smaller pull requests. Normally, I prefer to break this into multiple smaller pull requests. I can see two requests here, one for GPL driver and one for LED driver. Why do we break this down into two pull requests? Well, firstly, I do code review for NUTEX pull requests, and I understand that smaller pull requests are actually easier to review, quicker to review. The reason for that, larger pull requests have more code inside them. They take more time for us to read through all the code and review everything. And also, larger pull requests tend to generate more fixes during the review. You actually take more time to fix. And as you are fixing, all the fixes that are pointed out during the review, there's a higher chance that this pull request will become so hopelessly outdated that you'll not be able to merge this into NUTEX mainline. So therefore, I prefer smaller pull requests, right, with less code. They are easier to review, faster to approve. So with a smaller chunks of pull requests, we become more agile. If one intermediate pull request gets blocked, then we can think very carefully. Is this really worth pushing this pull request through? Should we give this up for now and come back later? Or should we just do the minimum, okay, to push this through, and then refine it in the next pull request? So we have a lot more options. If it's one huge pull request, we are stuck. If there's one tiny issue that's holding up everything, then we have to resubmit the whole huge pull request before we continue. If we have smaller chunks of pull requests, we can easily adapt on the fly, and change things as we go along. In the next video, we will talk about splitting a big pull request like this into a few smaller pull requests. Again, we'll use some scripts and copy the files over.